Hi, I'm Lou Brown from Spectrodyne, and today I'd like to talk to you a little bit more about the NCS1 measurement cartridges, which are really where the magic happens, if you will, in the NCS1. Our customers just love our cartridges because they're disposable, so you don't have to worry about cleaning, you don't have to worry about cross-contamination, etc. They only require 3 microliters of sample, which is really important for many people, and they're pre-calibrated. So you don't have to calibrate for each individual cartridge. They're already calibrated at the factory. So let's take a closer look at them.
The cartridges themselves are actually quite small, measuring about a ½ inch by a ½ inch square and consisting of 2 different pieces. I've taken one apart so that you can see the 2 pieces. The bottom piece is glass with gold electrodes for conductivity, and in my right hand you can see I'm holding the actual cast PDMS piece, which contains all the microfluidics. To load the cartridge, one simply pipettes 3 microliters of sample into the sample port, which is located right on top of the cartridge. Once that has been pipetted in, it's ready to be put into the instrument for measurement. To briefly review the principle of resistive pulse sensing, particles are passed through a nanoconstriction where voltage is applied. The volume of the particle creates a change in an electrical signal, which is what we measure. That change is proportional to the volume of the particle. However, what would happen if all of a sudden a particle came through that was larger than the nanoconstriction? It would clog it. And that's where microfluidics comes to the rescue. In this oversimplified diagram, you can see that how we've taken care of this problem is by placing a filter array between the sample port and the nanoconstriction where the actual measurement is made. Let's take a closer look at that. In order to let you see this a little bit closer, what we did is we took a fluorescence microscope and looked into the cartridge as particles were going through it. The particles were fluorescent as well, which you can see as the green dots here. Now this is actually up near the filter array, but it's kind of hard to see, so what I'm going to do is overlay an electron microscope image of the filter array on here so you can see it. The posts in the filter array are spaced exactly the same distance as the nanoconstriction, so what they do is they stop any particles that are large enough to clog the nanoconstriction from ever getting downstream where they could do that. So I've zoomed out a little bit here, and now you can see the particles moving from right to left as the flow is turned on, and you see the larger particles are being trapped upstream. Later on they actually get to the nanoconstriction, and here's what it looks like, and as you can see, there's no clogging occurring. The system can run very fast, up to about 10,000 particles per second. We use different size nanoconstrictions in different types of cartridges in order to cover a very broad range, as shown in this map. For each size cartridge, the number represents the size of the nanoconstriction. So for example, the C400 cartridge has a 400 nanometer nanoconstriction, and you can see here that it covers from 65 nanometers to 400 nanometers, and an approximate concentration range from 1 × 10 to the 7th particles per ml to 1 × 10 to the 11th particles per ml. The overall instrument range is from 50 nanometers to 10,000 nanometers, or 10 microns, and you can see we cover a concentration range from about 10 to the 4th particles per ml to 10 to the 11th particles per ml. Most customers only use one size of cartridge, but if you need a broader range, you can combine multiples together, as shown here. Here you see the same sample that has been run in 3 different cartridges in the NCS1. The software automatically stitches those 3 runs together from the different cartridges, and you can see that they line up quite nicely in the overlap regions. So this overall represents a graph showing particle distribution from 65 to 6,000 nanometers, and it's also showing over 8 orders of magnitude in concentration range.
Thanks for watching this video. I hope it was helpful to you. We've discussed the NCS1 cartridges in a little bit more detail, and please keep posted to our website. We will be adding more of these videos to talk about specific items related to the NCS1 over time. Thanks for your attention.